Hello friends. In the last video, we had seen the 8th tool of multivariate analysis in Minitab software, that is, cluster k-means analysis with the help of a practical example. In this video, we are going to learn the 9th and the last tool of multivariate analysis in Minitab software, that is, multiple correspondence analysis with the help of a practical example, for easy understanding and better clarity. So, let's begin. Multiple correspondence analysis. Multiple correspondence analysis is used to explore the relationships of three or more categorical variables. Multiple correspondence analysis performs a simple correspondence analysis on a matrix of indicator variables, where each column of the matrix corresponds to a level of the categorical variable. Instead of evaluating the two-way table of simple correspondence analysis, the multi-way table is collapsed into one dimension for this analysis. By moving from the simple to multiple procedures, you gain information on a potentially larger number of variables, but you may lose information on how rows and columns relate to each other. For example, a researcher wants to explore how different categories of automobile accidents relate to each other. The automobile accidents are classified according to type, severity, car size, and driver ejection. The researcher performs multiple correspondence analysis to examine how the categories in the four-way table relate to each other. Data considerations for multiple correspondence analysis. To ensure that your results are valid, consider the following guidelines when you collect the data, perform the analysis, and interpret your results. 1. You can have raw data or data in indicator variable form. If you have raw categorical data, then you can have one or more classification columns, with each row representing one observation. The data represent categories and may be numeric, text, or date and time. If your data are in indicator variable form, then each row also represents one observation, and you have one indicator column for each category level. 2. You can use supplementary data. You might have additional or supplementary data in the same form as the main data set for the analysis. These supplementary data could be further information from the same study, information from other studies, or target profiles. You can use the supplementary data to validate the components, often with a historical value or known standard. Supplementary data appear in the output, but do not affect the components. Example of multiple correspondence analysis. Let's continue with the same example. A researcher wants to explore how different categories of automobile accidents relate to each other. The automobile accidents are classified according to type, severity, car size, and driver ejection. The researcher performs multiple correspondence analysis to examine how the categories in the four-way table relate to each other. Conduct multiple correspondence analysis in Minitab. To conduct a multiple correspondence analysis in Minitab, please follow the steps. 1. Enter or copy the data to the Minitab worksheet as shown in the picture. 2. Select Stat, Multivariate, and then Multiple Correspondence Analysis. 3. Select categorical variables and enter car type, driver ejection, accident type, and accident severity. 4. In category names, enter accident names. 5. In the number of components, enter 2. Enter a number from 1 up to the number of categorical variables. Minitab can create plots with the components that you calculate. To display the column plot, you must have at least 2 components. 6. Click Graphs and select Display Column Plot. Keep the other setting as default. Use this option to display a column plot that shows the column coordinates for the principal components. 7. Click OK in each dialog box to get the results. We will get the results of an analysis in the session window and graph window. Interpretation of results. The analysis of indicator matrix shows the decomposition of total inertia into 4 components. The total inertia explained by the 4 components is 1. Out of the total inertia, the first component or axis accounts for 40.32% of the inertia, and the second component accounts for 25.20% of the inertia. Together, these 2 components account for 65.52% of the total inertia. Therefore, specifying 2 components for the analysis may not be sufficient. Adding a third component increases the cumulative proportion of inertia to 84.51%. In this analysis, Minitab calculates 2 principal components for data related to car accidents. Using the column contributions table and the column plot, the researcher can interpret the components in relation to the categories. In the table, the quality value, qual, indicates the proportion of the column inertia represented by the calculated components. In this example, the car size categories, small and standard, are best represented by the 2 components, quality is equal to 0.965. The ejection categories are the least represented by the 2 components, quality is equal to 0.474. The column labeled mass is the proportion of the class in the whole data set. Eject 0.037 and rollover 0.057 are relatively rare. The code column provides the column coordinates, which are displayed in the column plot. Correlation, core, represents the contribution of the respective component to the inertia of each category. For example, component 1 accounts for 61% of the inertia of the accident type categories, collies and rollover. Component 2 accounts for 93.6% of the inertia of the car size categories, small and standard. The contribution of the row to the axis inertia shows that eject contribution is equal to 0.250 and rollover contribution is equal to 0.291 contribute the most to component 1. The car size is small 0.771 and standard 0.158 contribute most to component 2. In the column plot, eject and rollover are most distant from the origin along the horizontal axis for component 1. This corresponds with the relatively high contribution of these categories for component 1. Because eject and no eject, as well as severe and no severe, are on opposite sides of the origin, component 1 contrasts these category values. Component 2 is shown on the vertical axis. The small car size is located far from the other categories on one side of the vertical axis. Therefore, component 2 contrasts the small car size with other categories. However, these results should be interpreted with caution, because 2 components may not adequately explain the variability of these data. This is all about the detailed illustration of multiple correspondence analysis. With this video, we have completed the study of all multivariate tools with practical examples. For references, I have taken some part of this very detailed content from Minitab. Now to end, please like this video if you have found it useful. Add your valuable comments, share this video with your friend and colleagues to improve and refresh their knowledge. If you want to get updates of such videos from our channel, please do not forget to subscribe to it. Click on the bell icon and select to get all notifications. And finally, thank you for watching.